Okay, let's get ready for index law number 2. First thing we're going to do is we're going to look at revising some of our, division skills and awarenesses. And we know 5 divided by 5 equals 1. 20 divided by 20 equals 1. Anything divided by itself equals 1. And so what we learn by that is that if I've got a division symbol and we make them look like fractions as we move on in maths, I learn by that well, if there's anything that's the same on the top and the bottom, they cancel each other out because they're equal to 1. So they cancel each other out. I'm left with A, or A over 1, which is just A. Alright, so same thing here. There's a B on top and bottom, so they cancel each other out. I'm just left with the 10. On this one, I have an A on the top and the bottom. Alright, and then it's a simple division. 20 divided by 10 equals 2. So this one leaves me with 2B, not 2B. What I now do is I can use this knowledge to get to index law 2 by doing the same thing as I did with index law 1. So I'm going to write this in expanded form here, and then as I just did, if there's anything on the top and the bottom, they cancel each other out. So I'm left with A times A at the top, or A squared. Same thing here, 1, 2, 3, 4, 5, 6, 7 over 1, 2, 3. Cancel, cancel, cancel. Left with 1, 2, 3, 4, or B to the power of 4. And so I then start using my mathematical brain and go, okay, let's skip this step. I've got 4 there and 2 there, and I've got to end up with 2. I've got 7 there and 3 there, and I've got to end up with 4. And if I really use my brain, I go, well, index law 1 is when I was multiplying and I added my indices. So index law 2, hey, I'm dividing, but I am subtracting my indices. So as a result, index law 2 looks like this. A to the power of m divided by A to the power of n equals A to the power of m minus n. So again, when the base number's the same, I'm dividing, I subtract my indices this time. So I just go 10 take 6 equals 4. 7 take 4 equals 3. 8 take, remember there's a 1 there, so that one equals 7. Alright, again when I bring in the numbers, it's the same sort of thing as what we did with the index law 1. So we'll look at the numbers first. 15 divided by 3, well, that's 5. And then I've got the same base number, so I do 5 take 2 and I get 3. 20 divided by 10 gives me 2. 7 take 6 is 1. So I don't even have to write the 1, so it's just 2f. Then we look at these ones and go, okay, what if my numbers don't divide evenly like those ones? So I look at it like I would just a fraction, and so I simplify. So I say, okay, what's my highest common factor? What's the biggest number that goes into 30 and 18? And I say, oh no, that's 6. So 30 divided by 6 is 5. 18 divided by 6 is 3. So I start and I have 5 over 3, and then I do my index law 2 with my g's there, g to the power of 5, divide by g to the power of 2, so I have 5 take 2, and it's g to the power of 3. Similar one here. Alright, okay, highest common factor is going to be 7. 14 divided by 7 is 2. 21 divided by 7 is 3. So I'm going to end up with a 2 there and a 3 there. 4 take 1 is 3, and 3 take 2 is just the 1, so I don't have to write anything. And ladies and gentlemen, in 4.5 minutes, that is index law number 2.